All right, so now we're moving on to the next section, and we're back in the book again still, and that's chapter 6, and we're now on section 8. And we're going to discuss areas and volumes of similar figures. All right, so we're going to focus more on the areas in this video, and we'll do a little bit of the volumes, but this is the last section before our next test. All right, so if I give you these two triangles, we know that these two triangles are similar because they have two congruent angles, and that means the third one would have to also be congruent. And as we talked about in our last video, if we can show you that two pairs of congruent, if two pairs of angles and triangles are congruent, then the figures are guaranteed to be similar. All right, and now if I tell you that this side is equal to 3, this side is equal to 9, and then I say that this side is equal to 6, and this side is equal to 18. All right, I ask you to find what is its similarity ratio. Or what is its K value? Right, so we're going to go from this triangle B to triangle A. So we're going to do a ratio from triangle B to triangle A. So we would then just do 18 over 6, and we see that that reduces to 3. So we know that this has a similarity ratio or coefficient of 3. So that means that if I multiply 6 by 3 and 3 by 3, that we will get the same value. All right, so it's something we did in our very last section. Right, now we're going to show how this relates with their area. Right, so if I ask you to find the area of triangle A, it would be 1/2 of our base times our height. So 1/2 of 6 times 3, which is equal to 3 times 3, or 9. So this figure has an area of 9 units squared. This one here would then be area is equal to 1/2 our base times height, so 18 times 9, which would then give me 1/2, which would then give me 9 times 9, or 81. All right, so we then have 81 units squared is this area. All right, so now if we create the same ratio that we did for our similarity ratio, so we did triangle A or triangle B to triangle A. If we do the same thing, but now with our areas, we have 81 over 9, and this reduces to 9. So now what relationship can you say we can do from our similarity ratio to our area? Right? What can you notice that we can multiply, or what can we do to this number 3 to get our number 9? Right? And we can square it. If we square our 3, we get to our 9. So our area has the same ratio as our K squared. So whatever our similarity ratio is, we can square that, and that tells us what the ratio is for our two areas of our figures. Right? It might be confusing right now, but I'm going to show you a little bit more in detail what I mean just right now. All right, so since our two triangles are similar, that means everything is being multiplied by the same K value, right? By our same similarity ratio. So that means that the height and our base are both being multiplied by K. And so that means we are adding a K squared, K times K, which is then equal to K squared. So that's why it works. But what it's saying is that the area of our two figures has a similarity ratio, or has a ratio of our similarity ratio squared. So we can use this to help us solve problems, right? So the first thing that we need to identify is what is our similarity ratio? And then from there, we can square that number, and that tells us what the ratio is between our areas, like we did on the problem above, where our similarity ratio was 3, and then the ratio of our two areas was 9, which is 3 squared. All right, now let's go ahead and do a problem and see what I mean by this. Actually, before we do the problem, I'm going to show you how we can use this, what we just learned, in order to help us solve a problem. All right, so if we erase some of this, and we erase this side here, or this side here as well, and we're asking, or I'm sorry, if we keep this here as a 9, all right, and I say, what is the area of triangle B? All right, well, we know the area of triangle A, but we don't know the area of triangle B. So what we can do then is we first identify what our similarity ratio is. So we can then say, well, 9 divided by 3, that gives us 3. All right, so that's our similarity ratio between the two triangles based on what we have here. All right, so to find the similarity ratio between our areas, we would take that 3 and we would square it. So then that is equal to 9. Right, and then you can do this a few ways, but you can create a proportion now. We created our similarity ratio to be triangle B over triangle A, so we can create a ratio with our area. Well, we don't know the area of triangle B, so we can just leave it. I'm going to put it as B instead. We can leave this as an unknown area. Our area of triangle A was 9, and this is equal to our ratio of 9 over 1. And now we can use cross multiplication to solve. So B times 1, that still gives us B, and 9 times 9 is 81. And since we're dealing with area, we know it would have to be units squared. Right? So that is how we can use this to solve. So now let's go ahead and do an example now that we discuss this a little bit further. All right, so here we're asked to find the area of this triangle. So the first thing that we have to do, I guess I cut off some of the problems, is it tells us the two triangles are similar, right? If I didn't tell you the two triangles are similar, you cannot use this. But it will tell you in this example that they are similar. So the first thing we have to do then is figure out what is our k equal to. So we need to create a ratio. All right, so now I'm going to just go from the bigger triangle to the smaller, so my ratio is going to be 8 over 5. Well, if I want to solve for what my area is, I need to take my k squared, which then means I need to square my 8 over 5. And when we have a fraction, we square both the numerator and the denominator, so that means our k squared, or the area, is equal to 64 over 25. All right, so now that gives me a ratio, 64 over 25. Now I'm going to create a proportion. So I compared this triangle, the bigger one, to the smaller one to get this ratio, so I need to compare my areas the same way. So then my area, I don't know A, the bigger triangle, over 6.2. Right, now we can cross multiply, so we can do 25 times A, which is 25A, and then we can do 64 times 6.2, which is then going to give me 396.8, and then we will divide each side by 25, and that will give me that my area is equal to 15.872 centimeters squared. All right, there is a little bit of a different way that you could have done this, and it's your call. I can show you in class what the other way is, or I'll show you right now. The other way that you could have did this is, rather than creating it and keeping it as a fraction, you could have made this as a decimal. So 64 divided by 25, and that will give you 2.56. Right, and then if we did 6.2, so now all we would have to say then is our area of the triangle we want to solve for is the area of the other triangle times 2.56. So 6.2 times 2.56, as you'll see, gives us the exact same area that we had before of 18.72 centimeters squared. All right, the only problem is when you do it this way, you may mistakenly flip your ratios without knowing. So then you would have to do whatever triangle you're trying to solve for would have to be the one in our numerator. So you would have to go from here to here. I prefer doing the proportion because it allows for you to remember or see that you're doing it the right way, and you're not changing your ratios, so you're not going from the smaller to the big in one and then the bigger to the smaller in the other, but you're staying consistent. By doing it like this, you may mistakenly create the wrong ratio for this part, but that is how your book shows it, so you can do it that way as well. There's just a couple more examples we're going to go through. All right, so for this one, we're given a few pieces of information. We're asked to solve for the area of triangle ABC. So we want to know, what does this area equal to? All right, I just redraw these triangles first, and I filled in the information. So here, 88 degrees. So I just separated the big triangle ABC and the smaller one. All right, we know that these two triangles are similar because we have two congruent angles. So that means the third ones would have to be congruent, and that means that these are definitely guaranteed to be similar. Right, so it also tells us that this has an area of 4.2 centimeters squared. Right, this is our area. So what I want to do now is I need to create my similarity ratio. So my k, I'm going to go from the bigger triangle to the smaller one. So that is then equal to 6 over 4, which reduces to 3 over 2. All right, I would advise that you reduce when you can, because it'll make it easier when you're solving with your squares. All right, so now if we want to solve for the area, that is equal to my k squared. So I need to take my k and I need to square it. We squared both our numerator and denominator, so it's 9 over 4. So there was my ratio of 9 over 4. So now I need to create a ratio with my areas of my triangles going in the same way. I did not know the area of the bigger triangle, which was what I put my numerator, so that is what I'm solving for. So I'll say area over top of the area of the smaller one, which they gave me was 4.2. Right? I will then cross multiply. So then this will give me A times 4. I'll do it over here, so it's 4A. 9 times 4.2 is going to give me 37.8. Divide each side by 4. And that gives me that A, my area of my bigger triangle, is equal to 9.5 9.45 centimeters squared. All right, so that means what I'm tracing here is 9.45 centimeters squared. All right, so the entire area is 9.45 centimeters squared. Right, it then asks me to find the area of the quadrilateral ABED. So I want to find this area. Right, well, if I know the entire black image is equal to 9.45, and I know that this smaller triangle had an area of 4.2, what could I do with this total triangle and this smaller part in order to get the red missing? I can subtract them. Right, because if I know the entire area of the figure and I know this portion, that means the remaining has to be what's left over. So I can then just do 9.45 and I can minus 4.2 from it. So that means the area of the quadrilateral is equal to 5.25 centimeters squared. Right, we didn't have to do any formula. We didn't have to multiply or find anything. Once we knew the area of the entire piece, we could subtract out the piece that we knew to find the missing area here. All right, then now we have left is to talk about volumes, and this will just be a little bit quick. All right, volume is very similar to area in that we're going to be able to solve problems by using our similarity ratio, but now when we use volume, we're multiplying our k to our length, our width, and our height. So we're multiplying our k 3 separate times. So that means the volume will have a ratio of our k cubed. Right, but we do the exact same thing that we did with our area in order to solve for this. All right, so let's just do a problem real quick. All right, so the first thing I would do is tell you that these two cubes are going to be similar. Right, and then from there we will find the volume. All right, if I tell you that these two cubes are similar, I'm going to just erase one of these sides because you can't have everything. But if I tell you that these two cubes are similar, we can find the volume of the first one, and that would be 12 times 8 times 6. So 12 times 8 times 6 will give me 576 units cubed. Here I have my one side, which will correspond to this 12. So I can then find my similarity ratio, and I'll go to bigger to the smaller. So I'll go from here to here, so it's 12 over 6. That reduces to 2. Well, my k is equal to 2. Well, when I'm dealing with my volume, I need to cube it, so it becomes 2 cubed, which is then equal to 8. So now I have my ratio of 8 over 1, and that went from my bigger figure to my smaller. So that means the volume of my bigger figure needs to be on top, and then I'm solving for the volume of the smaller figure below. And now I would cross multiply. This will give me 8v is equal to 576. Divide each side by 8. So then my volume of the smaller figure will be 576 divided by 8, and that will give me 72 units cubed. All right, so when you're solving this is why I don't think you should use the way that the book does. I think you should create these ratios because it allows you to make sure that you are staying consistent. Someone might mistakenly do 576 times 8, and you may get it wrong that way. Right? If you were going to use what the book said, you would have to go then from the one that you don't know to here, and you would have to have your similarity ratio of 1/2, and after you cube it would have to be 1/8, and then you would multiply 1/8 times 576. So I think by doing it the way I'm showing you here, it allows you to make sure that you stay consistent. All right, that is it for this video.